All right, everybody, welcome back to Burt's Basics at Box Elder High School, Medical Anatomy and Physiology. Today we're finishing up some chemistry. So today we're doing Standard 2 Concept 6 through 8. We're learning a little bit about pHs, acids, and bases. So let's go ahead and get started. These are the things that you need to know. So you have to define pH, know the difference between acids and bases, and then tie that to something that's a real world application like the pH of my blood, which we talked about homeostasis in one of our prior videos, and we just got to make sure that we know how important pH actually is. So if I asked about pH, or a lot of people probably already know that it's tied in with acids and bases. Now, someone on the street probably knows that food tends to be acidic. Pineapple is pretty acidic. There's certain fruits that are acidic. Orange juice is pretty acidic. Some people have problems with acid reflux and the acid coming up in their esophagus. There's a lot of people know about acids. Lemons are acidic. Bases, on the other hand, are kind of the more mystery of science. They know they're not acids, but most time bases, if they do know them, they're going to be like, oh, those are like cleaning products like lime and bleach and some of those other things, which is somewhat correct. And so what we want to do is we want to take that basic knowledge and make it a little more advanced. So what we're going to do is we're going to amplify it. So let's talk about the things you need to know about bases. So the first thing you need to know about bases is there's a scale. I'll put myself in the middle for now. The pH scale goes from 0 to 14. And it's a scale to measure acids and bases. And so let's start with the basic. If I have a pH of 4, over here I'm in a 4, I am in the acid zone. So from 1 to 6.9, that is an acid. At a pH of 7, I'm right smack dab in the middle. I am neutral. We'll explain that in just a second. And if I go above 7.1, or 7.01 actually in theory, all the way up to 14, I am a base. So right away, you could have a question as simple as that. What is the pH of a substance? Or if I have a pH of 4, what am I? If I have a pH of 10, what am I? So know your pH scale. Now in this class, we want to go above and beyond. So what I have down here at the bottom is a list of the some common acids. You've probably recognized these. There's phosphoric acid, sulfuric acid, acetic acid. But if you notice on all these acids, they're really cool because they all start with the letter H. That will come in handy in just a second, because when these guys say sulfuric acid, you drop him in water. All of a sudden he falls apart, and now you finally get the idea why we call it the pH scale. Notice the P is lowercase and the H is uppercase. That's for a reason. The P stands for potential. Some people say it stands for power, but it's the potential hydrogen concentration. So acids and base is all about hydrogen. So if you take this acid formula here and you drop in water, they fall apart into H plus. Now H plus is just hydrogen ion. It's just an ion of hydrogen. Ion is an element that has a charge. It's a cation because it's positive. But if I have a ton of H plus, then I'm an acid. And now let's go to the bases. You notice this says you don't pronounce this loa, okay, or kua, okay. The OH in chemistry is called hydroxide. So this is pronounced lithium hydroxide, potassium hydroxide, sodium hydroxide. Okay, these are all strong bases, and you notice a trend on them. They all end in OH. As soon as they dissociate, they form the almighty OH minus. Now this is also an ion. You can see the word ion there. We pronounce this OH minus hydroxide. So when you guys hear the word hydroxide, you better be thinking bases. So if we go back to our scale here, if I have a ton of hydroxides, then I am a base. The problem is you can't have them both at the same time. So let's go to the next picture. This is probably the best picture if you really want to understand acids and bases. At a pH of 0 and 1, you are a strong acid. The red represents hydrogen ion. So at a pH of 1, 2, we're talking gastric juices, which is stomach juices, lemon juice, vinegar, apple juice. There are so many red, okay? That's all hydrogen ion concentrations. But notice what happens if I go to pH of 1, 2, 3, 4, 5, 6, 7, 7 right there, 8, 9, 10, all the way to 14. You can't even see the red anymore. It's there. It's just very low. So a base has very low hydrogen ion concentration. But now check out the base. If I'm a base, household ammonia, milk of magnesia, borax, okay, bleach is up here somewhere, you have a ton of blue. In this case, blue represents hydroxide ion concentration. Remember, OH minus is hydroxide. Another question you might have is you're going to see this word alkaline a lot. Don't panic about that word. That is just another word for base. So at pH of 14, you have a ton of hydroxide ion and very, very little hydrogen ion. So now let's go to a pH of 7. Most of you know what a pH of 7 is. pH of 7 is neutral. And now let me blow your mind to tell you why. There's only one thing in the world that is neutral, and it's water. You guys are so used to writing water like this, H2O, which is great. That's a polar compound. Okay, they're sharing electrons. But check out when water can dissociate. He falls into OH minus, which is hydroxide, and H plus, which is hydrogen ion. So if you want to look at it this way, a water is half acid and half base. That's why at pH of 7, the hydrogen ion and the hydroxide ion are the same. That's why water is neutral. If you want to think water is half acid, half base, go ahead. It is neutral. It's right in the middle. It's half acid, half base. They cancel each other out, and that's why water is so amazing. Okay, now let's apply it to us. Okay. Unfortunately, the pH of blood is very, very important for us. It's part of our homeostatic pathway. We have to keep it, I always say 7.4. And you can see why. So here we got 735 to 745. Our pH has to be 7.4. And now let me tell you why, because then we'll get to these words. You have a lot of enzymes in your body. Enzymes are proteins that are just folded in certain ways to make chemical reactions happen in a timely manner. They're amazing. The problem is they're very sensitive. They're sensitive to temperature. They're sensitive to pH. And if I go out of my homeostatic pathway or my homeostatic bubble of pH, they start to fall apart, which is called denaturing. If your proteins begin to denature, we're in trouble. So if we look at this, this is the name where we want to be in. If I go above that, if I go 7.45, 7.5, 7.6, 7.7, I'm getting more and more basic, So they call this alkalosis. Now remember, I wish they called it basidosis, but they don't. But remember, alkaline and basic is the same word as basic. So if you go to the doctor and he says, ooh, you have alkalosis, it means your pH is too high. You're too basic. Now this, if you're a chemistry person, will drive you insane, but it should make sense. If I go below 7.3, 7.2, 7.1, I now have a condition called acidosis. Now that means I'm on the acidic side of where I need to be. I'm going too acidic. But be careful. On a test question, 7.2 is actually a base. It's just in our bodies, we're below what we're supposed to be. So they call this acidosis. Acidosis makes you feel really sick as well. And I thought you guys would like the beautiful pictures on the end, because if you get too far out of homeostasis, it's very scary for us. So blood pH is super important. So that was your pH lesson, guys. I hope you learned something. So do me a favor, knock out this quiz. The answers are on the next page. I hope you feel a little bit better on this, and I look forward to you coming back and getting more information from me. We'll see you around.